Hello, my friend. In this video, I am going to clarify when to use machine learning. My name is Yusuf and I am going to present this video. Here you see the list of outline. First, we clarify when to use machine learning. We provide a definition from machine learning and then we discuss in what situation we should use machine learning based on the provided definition. We use machine learning when the system has the capacity to learn, they are pattern to learn, and they are complex. We use machine learning when data is available or it's possible to collect data. It's a predictive problem. Unseen data share pattern with the training data, and we also discuss about other feature and other situation that we need to use machine learning. And finally, I will present the reference. Okay, when to use machine learning? Uh, Overall, in two main situations, we should use machine learning. The first one is that we cannot code the rules. Okay, many human tasks, such as recognizing whether an email is spam or not spam, cannot be adequately solved using a simple deterministic and role-based solution. Okay, we have some problem such as spam detection that we cannot solve them using role-based system because the spam pattern are frequently changing and they are dynamic. Okay, and the second case is we cannot scale. Okay, you may be able to manually recognize a few hundred emails and decide whether they are spam or not. Okay, for a limited number of the email, maybe manually you can recognize which one is spam, which one is not. However, this task becomes tedious for millions of emails. Okay, imagine you have a million of email. You cannot use manual approach, and the ML solution are effective at handling large scale problem. My friend, let me further classify. Overall, if I want to provide further explanation, I would say that we use machine learning when there is no mathematical model of the problem. For example, for image recognition, there is no mathematical model of the problem. For example, in natural language processing, for example, for sentiment analysis, there is no mathematical problem. For example, in autonomous driving, the car has to navigate a complex and dynamic real world scenario, and we cannot mathematical model this environment. Okay, in this situation, we need to use machine learning. Okay, um, another case is that some problem are MP hard and they are MP complex and we cannot solve them easily. For example, traveling salesman problem is an NP-hard problem, and in this case, we use machine learning to approximate the optimal solution. Okay, okay. So let me repeat: when there is no mathematical model of the problem, when the problem is complex, the problem is NP-hard, we use machine learning to approximate the solution. Okay. What is machine learning? Here we provide a definition of machine learning, and then in the next slide we elaborate on each item. Machine learning is an approach to learn complex pattern from existing data. Okay, machine learning is an approach to learn complex pattern from existing data and use this pattern to make prediction on unseen data. Okay, learn complex pattern from existing data and use this pattern to make prediction on unseen data. Okay, okay, now let's discuss about learning. we use machine learning when the system has the capacity to learn. For example, as a computer scientist, all of you know that, for example, a relational database doesn't have a capacity to learn. We explicitly specify the relationship between different columns. Okay, there is no capacity to learn. Okay, for example, a recommendation system like Netflix learn user preference from interaction and data to make personalized content suggestion. Okay, a recommendation system like Netflix learn user preference to make personalized content suggestion and continuously improving through feedback. Okay, in this scenario, when the system has the capacity to learn, we should use machine learning. The second case that demand machine learning is complex pattern. They are pattern to learn and they are complex. Okay, we can observe some pattern in the problem over time, and these patterns are complex. In this case, we need to use machine learning. For example, a well-known example is fraud detection. Okay, a fraud detection system exemplifies an ML system that learns complex patterns by analyzing extensive transactional data to identify potentially fraudulent activities. Okay, in fraud detection, patterns are frequently changing. There are some patterns are available, and most importantly, in fraud detection, these patterns are complex. In such a situation, we cannot use role-based system. We cannot utilize expert system to address the problem such as fraud detection, and we have to use machine learning. Okay, existing data. We use machine learning when data is available or it is possible to collect data. Okay, data is available. For example, this is the case for supervised learning, unsupervised learning, or it's possible to collect data. For example, in reinforcement learning, we have the possibility to collect data online. Okay, let me convey let let me clarify the issue with the example of Google PageRank algorithm. Okay, Google PageRank algorithm leverage the available data on web page link to rank the importance of page in search result. Okay, Google PageRank algorithm utilize the available data on web page. Okay, so data is available, and in this case we can use machine learning by analyzing the structure and connection of the web. Google can predict which page are most relevant to user query. One thing that I would to add to this slide is that okay, data is available or it's possible to collect data. This is a basic condition for using machine learning. Also, uh, when we use machine learning for a problem, the problem should be framed as a classification problem, regression problem, clustering problem, or a Markovian problem. This is also important. Okay, prediction or problem that we want to use machine learning for solving that should have a predictive nature. This is very important. For example, you consider house price prediction using machine learning. We want to predict the price of house by using machine learning. It is obvious that the problem has a predictive nature. House price prediction using ML analyze historical data on property feature and market condition. An ML model predict future house price. Okay, analyze historical data on property feature and market condition, and then use the ML model to predict future house price. Okay, Mm, the problem should be predictive and has a predictive nature. Okay, unseen data. Unseen data share pat we should use machine learning when unseen data share pattern with the training data. Okay, let me tell you in simple language, the the, data distribution between training data and unseen data should be same. The training data and the unseen data should follow the same pattern. Okay, for instance, a model trained on app downloaded data from 2008 may not accurately predict download for Christmas 2020, 2020. Okay, a model trained on app download data from 28, okay, may not accurately predict download for Christmas 2020 due to change in user behavior and market condition. Okay, we trained the model in 2008, and the user behavior and market change over time, and we cannot use this model in 2020. Okay, it means that the pattern of data for training data and for the unseen data should be similar. Okay, they should be from the same distribution. The training data must be relevant to the prediction context for the model to perform well. Okay, other feature, the problem should be repetitive. When a task is repetitive, each pattern is repeated multiple times, which make it easier for machine to learn it. Okay, the problem should have the repetitive nature. This is very important. In this case, we can use machine learning. The cost of rank prediction is cheap. This is also very critical factor. ML is especially suitable when the cost of a rank prediction is low. For example, one of the biggest use case of ML today is in recommender system, because a bad prediction can be easily neglected by the user. Okay, so we use the machine learning when the problem is repetitive or the cost of rank prediction is cheap. Also, we use the machine learning when the pattern are constantly changing. This is very important. If your problem involves one or more constantly changing pattern, hard-coded solutions such as handwritten rules can become outdated quickly. Okay, I think this is clear. Because ML learn from data, you can update your ML model with new data without having to figure out how the data has changed. Okay. So overall, the problem should be repetitive. The cost of rank prediction is cheap, and the pattern are constantly changing. My reference is this book, Designing Machine Learning System. Thank you very much for watching this video. If you learned something from this video, I appreciate to like and subscribe.